Hi everyone, welcome back to Mind and Maths with Amna. Today we're starting a three-part series on phase diagrams in macroeconomics, which helps us understand not just where equilibrium is, but how the economy moves over time when it isn't in equilibrium. In part one, which is today's video, we are building our foundation. We'll go step by step through firstly, the IS curve and how output adjusts when the good market is out of equilibrium. Then the LM curve and how the interest rate adjusts in the money market. And finally, we'll bring both markets together to draw a combined ISLM phase diagram, including the directions of motions for both output and the interest rate. So by the end of this video, you'll understand exactly why the arrows point the way they do and how to read dynamic trajectories in the ISLM system. So let's begin. I've already written out the definition of the IS curve, which is that the IS curve represents all combinations of interest rate and output where the goods market is in equilibrium. So over here we're talking about the Keynesian cross diagram where the goods market is in equilibrium, where the aggregate expenditure line actually intersects the 45-degree line. This is where supply is equals to demand, or aggregate demand is equals to aggregate supply, or simply just aggregate demand being equals to output. So let's just first start by a revision, or basically a recap of how the IS curve is actually derived. So I'm going to make two diagrams. First, I'm going to make the Keynesian cross diagram, and then I want to make the IS curve right below it. The reason being that they share the x-axis variable, so it's kind of nice to just make it so that they're one is above and one is below. Okay. So the Keynesian cross diagram has a 45-degree line. So therefore, aggregate demand is equals to aggregate supply along this line because it is a 45-degree line. And then we have the typical aggregate demand curve. So what we can say, we know that aggregate demand is equals to consumption plus investment plus government spending, and when we have an open economy, then net export as well. We know that investment is basically negatively related to the interest rate, because if the interest rate is increased, then it becomes very difficult to get loans because you have to pay back more, so it's harder to get loans. With this, the level of investment in an economy falls because people don't want to borrow that much money anymore, and which basically shifts the aggregate demand curve downwards. So from an equilibrium point A, we're going to end up with another equilibrium right below it. So the aggregate demand curve shifts downward and we are at point B. We can take this down and we can show that there's been basically a fall in output because of a rise in interest rate. So output went from Y0 to Y1, and we can label this here Y0 to Y1, and the interest rate was rising, so I know the value of R1 has to lie above. So I can write R1 here and suppose an R0 here. This is going to be my point A. This is going to be my point B. And once I join these two lines, I will get my IS curve. So remember that all points on the IS curve are equilibrium points. So all points on the IS curve show an equilibrium, specifically in the goods market, right? So in this scenario, we know that on all points, output is basically at an equilibrium. We can denote this by just putting a Y star here. And this is the value where the aggregate demand curve intersects the aggregate supply. So this was like we've studied this in first year undergrad economics, but I still wanted to give a recap on how it is actually derived. Okay, moving on to the next concept. Now that we have the Keynesian cross diagram, let's kind of pay more attention to it. Let's see what happens, how output behaves around this equilibrium. So suppose this is my equilibrium. I'm interested in how output behaves when it deviates from this equilibrium. So this is my 45-degree line, and this is my aggregate demand. Okay, we can see that towards on this shaded region, let's just shade it along this line, we have a situation where the aggregate demand curve actually is less than output, right? And along this part, we can see that the aggregate demand curve lies above the 45-degree line. So therefore, on these points, we have aggregate demand exceeding output. So remember that we have, just in case people don't know the functional forms, usually the consumption function, let's suppose it's written as autonomous consumption, marginal propensity to consume, and let's suppose we have a tax rate K and we have a proportional tax. Let's suppose that the investment function is an I bar minus let's just say C R, and then we have government spending, which we can take as autonomous, and let's just take net, or just let's suppose we have a closed economy, that'll be easier. We know marginal propensity to consume lies between 1 and 0, so does the tax rate. Okay, so the aggregate demand curve is basically C plus I plus G. And when we put all of these functions in, I'm going to put all the things that are not dependent on income here, and this is what I'll get. These are the variables, yeah, right here. Okay, the reason why I've written it this way, because this is sort of like I just want it in the following format: y is equals to mx plus c, c being the intercept, x being the variable on the x-axis, and y being the variable on the y-axis. So I have AD on the y-axis, I have output on the x-axis, and this is basically my intercept. So this is the equation, and I can see that this is basically the this is the intercept and this is the slope. We can see for stability we need the slope to be less than 1. We'll talk about this later as well. I'm just writing it right down over here. Why do we need it to be less than 1? Let's focus on, zoom in on this area, or let's just start with this area. Over here on the left side, wherever output is below the equilibrium, we have a scenario in which aggregate demand exceeds output. This is a situation where there is an excess demand for goods. So in our model, we assume that prices are fixed and the economy is basically demand driven, which means basically if there's an excess demand of goods, there's going to be a fall in the inventories, and it's going to basically lead to a rise in output. So what happens is when output rises slowly, the excess demand for goods is eliminated. So this leads to an excess demand which is eliminated eventually. So what we need to remember is that when we're on the left side of y star, the change in output with time is greater than 0. So therefore I can write the conclusion here that on this side y dot is greater than 0. That means output changes positively with time. Conversely, what happens to the on the other side? It's kind of symmetrical kind of logic. If output exceeds the equilibrium, then we have a situation where aggregate demand is less than output. Therefore, we have excess supply of goods in the economy. So therefore, there's going to be a rise in the inventories. The firms are going to basically increase their stocks, and this is going to take away goods from the economy, and therefore this will eventually eliminate the excess supply. So therefore we know that output actually reduces. So we have a scenario on this side where we know output reduces till the economy converges back to the equilibrium. So what do we see right here? We can see that there is this kind of negative relationship between the change of output with respect to output. Let's make this. So sorry, this should be like blue. Okay. I hope I'm going at a slow pace so nobody feels overwhelmed. We have output on the x-axis. We have the change in output with respect to time on the vertical axis, and we have this negative relationship. We've just shown that whenever output is less than the equilibrium, actually in this case it's more than the equilibrium in this part because it's greater. And let me write it out. When this region y is less than y star, and we know at this region we have change in output greater than 0. So that is why this parts come on the positive side. And in this region y is actually greater than y star. Therefore I know this diagram has to lie below, where all the values of y dot are negative. If this happens, then yes, the economy does converge eventually. If it deviates from the equilibrium, it will eventually, over the span of time, 5 to 10 years, depending on the shock, will converge to this equilibrium. In conclusion, if you want stability, the stability condition is that the derivative of y dot with respect to y has to be less than 0. We call this the stability condition. And since the variable under concern is on the x-axis, so the x-axis has output on it. Therefore, whenever y dot, which is the change in y with respect to time, is greater than 0, the arrows that will be given for this is going to be east. And whenever y dot is less than 0, the arrows that we're going to use are going to point to the west. Let me just erase this. So we're going to make arrows like this when we have y dot greater than 0. Oh, that's too big. Let me reduce that. Like this. And west like this. Okay. So now we're going to use this to make the phase diagram for the IS curve. So I don't want to waste time by making this again. So since I have an iPad, I'm just going to copy paste it and show you guys how to make the phase diagram. Okay, so remember, all points on the IS curve have are points that denote y star. Okay, and we've seen that whenever output is less than y star, we experience an increase in output. So we want arrows that point to the east. And whenever output is greater than y star, then we have a y dot which is less than 0. So the arrows have to point on the west. So let's make this diagram. So this is output, this is interest rate, this is the IS curve. It's also actually in many texts called the y dot is equals to 0 locus. So we can use this vocabulary as well. So let's suppose, remember, all points on this denote y star. So let's just take an arbitrary y star. I'm just going to take, let's suppose I'm just visualizing this. I'll drop this later. Suppose I'm just looking at this. So remember, at this exact point, whenever output is greater, this part right here, whenever output is greater, I need to make, I'll just shade it so that nobody gets confused. I'm talking about this part. So whenever output is greater, I want to make an arrow which points to the west. Okay, and along this side, whenever output is less, I have to make arrows which point towards the east, something like this. Okay, I told you guys that all points on the IS curve are in fact equilibrium. So this y star actually is on all points. Therefore, if we analyze each and every point, we're going to be left with the same directions. So I'm going to get this here. I'm going to get this here. I'm going to get it again over here. Similarly, these arrows will also be repeated in all directions to the left. So I'm just going to put this here just to show you guys how this works. So this is like this diagram shows, this is the phase diagram, and it shows the direction of movement if the economy diverges from this point or any point on the IS. For instance, if it says if the economy was suppose at this point and because of some shock it went over here, the phase diagram basically shows that the economy is going to push it right back to the equilibrium. It's going to take a while, but the arrows indicate that if the economy is stable, then even if the shock takes us to the right side, the stability conditions are going to push us back to equilibrium. Okay, let's do the same thing for the money market, and then I'm going to end the first part of this lesson, and I would recommend you basically absorb this before moving on to the next two videos. Okay, for the money market. So, the money market. Remember, these are the money market shows basically we derive the LM curve from the money market, and the LM curve is, maybe I should write this down, that LM curve is the combination of interest rate and income, where the money market is in equilibrium. For simplicity in this video, I am assuming a central bank which practices monetary targeting. We know this is no longer done. Central banks are now either inflation targeting or interest rate targeting. However, we're solving this assuming that the central bank is follows monetary targets, because it's just going to be easier for us to analyze. Okay, just like we derived the IS curve, I'm going to quickly do a recap of how the LM curve is derived. This is a very basic derivation because it's covered mostly in the first year of economics for undergraduate students. So I don't think I need to emphasize too much on how this is made. We have R on the vertical axis, and we have real money balances on the x-axis here and output on the x-axis here. So we have a vertical money supply curve, and it's vertical because it's exogenously set by the central bank, and we have a negatively sloped demand curve. So the demand curve is a function of output and interest rate, and this is basically just the initial demand curve. And I'm going to say that this is my initial point A, and I'm going to take this point over here, and I'll say that this is associated with point A right here. So I'm just going to say that this is Y naught, and this is the initial interest rate R naught. So whenever there's a rise in income, it leads to a rise in the money demand, which is basically a video for another time. And the money demand curve shifts upwards, which will basically lead to a rise in the interest rate. So visually this goes right here. We end up with a higher level of interest rate, and therefore we get a positively sloped LM curve. This is output, this is point B. Once I connect these dots, I'm going to obtain a very beautiful LM curve. Remember, the LM curve can be flat because of a liquidity trap, and or it could even be vertical, but we are right now just taking a simple scenario in which the LM curve is positively sloped. Okay, so we know that, suppose we know all markets are in equilibrium when the supply equals demand. Let's assume only two goods, financial assets exist in the money in this market, which is money and bonds. So the supply of money and the demand for supply of bonds should equal the demand for money and the demand for bonds. Therefore, we have, if I just take money on the right side and bonds on the left side, I'm going to have this equation that excess supply of money is the same as excess demand for bonds. What this means for us is that if there is any excess supply of money, it implies that there is must be an excess demand for bonds, and therefore the price of the bond must rise, which will lead to a fall in the interest rate. Similarly, if there is an excess demand for money, it means that it will create an excess supply of bonds, and therefore the price of the bond will fall and through a rise in the interest rate. Okay, let's try to show this diagrammatically. So suppose we have, let's start with on a position of equilibrium, and then let's deviate from that equilibrium. So this is the vertical money supply, this is the negatively sloped money demand, and this is my equilibrium. Let's consider scenarios in which we actually deviate from this equilibrium. Okay, so this is my money demand and this is my equilibrium interest rate. Okay, so this is my equilibrium interest rate. Suppose the interest rate is deviates because of whatever shock, and and I'm actually assuming that inflation expectations are 0, so therefore real interest rate is the same as nominal interest rate, for simplicity. Okay, so whenever interest rate exceeds R star, we are basically in a over here. You can see that the money supply is higher than money demand. So this gives a scenario where money supply exceeds money demand, and therefore we have an excess supply of money, and I've just explained how this should lead to a fall in the interest rate. So therefore that means the value of R dot is going to be less than 0. So whenever we are in a scenario where the interest rate is higher, for instance, let's suppose over here, the economy is going to push us back to R star. Similarly, the logic goes both ways. If you've understood this, you'll understood what happens if it the disequilibrium is on this side. So suppose R is less than R star. Now you can see that on any point here, money demand exceeds money supply. So when money demand exceeds money supply, we have a scenario in which there is an excess demand for money, and we've just discussed how through the bonds market this would lead to a rise in the interest rate, and therefore which means that R dot is greater than 0. So basically the economy converges back to R star if it deviates. So how do I show this? Let's make the diagram again with, let's see how R dot behaves with R. We just saw, let's suppose this is R star. We know that when R is less than R star, Y should be greater than 0. So whenever we are on this side, R dot should be greater than 0. So this side, it's going to be greater than 0. And whenever R is greater than R star, so basically this region, we're going to have R dot is less than 0. So therefore the line goes like this. So we can see that there, for stability to happen, we claim that this is basically stability because we are after disequilibrium due to any shock, we are converging back to R star. Therefore, we know that in this case, what is the stability condition is that there is a negative relationship between R dot and R star. So you have to remember that this is in fact now the stability condition. So what impact does this have on how do I make the phase diagram for the LM curve? Remember, all points on the LM curve give us R star. So along all these points, we have an equilibrium. So this is R naught star. R naught star. This is another interest rate which is equilibrium. So this is another interest rate which is equilibrium. So let's just combine this information on sorry, let me zoom in for you. We had R on the vertical axis and we had output on this axis. We've already shown that this is a positively sloped curve. We can also call it the R dot is equals to 0 locus. All points on this curve have a point, the value of R being R star. So on all points we have R star. Let's take an arbitrary point. Let's say this is R star. We just wrote down these conclusions. I'll write it down again, that whenever R is greater than R star, we have a scenario where R dot is less than 0, and whenever so basically along this line we're going to have a decrease, and whenever R is less than R star, interest rate is going to rise. So interest rate is going to rise. Since all points on the LM curve are in fact equilibrium points, therefore this can be extended to all points below and above. So you can write this here, you can take this here. Okay, so I hope nobody's suffering emotionally so far. So a little tip that I have is that when we can think of the direction of motion in terms of a velocity vector. Whatever is on your x-axis, we're going to, so we have output on the x-axis, so that's, we're going to see the change in output over here, and you're going to change in interest rate over here. This is going to always tell me either east or west, and this is going to give me arrows which are either north or south. Okay. So it's time to wrap things up. We're just going to put all of whatever we've learned together. So we have the goods market and the money market both in equilibrium. So I'm just going to put make a diagram in which both of them are in equilibrium. So ISLM combined, this is the IS curve and this is the LM curve. We said all points above the LM curve will have an arrow which points to south, and all points on the downside are going to have a north. For the IS curve, we said all points above the IS curve are going to give us a west. Sorry. Oops. west, west, and all points below it are going to give us an east, east. So now we have the directions movement, and now it's easy to see if the economy is convergent or not, converging or not. For instance, I know the overall direction this is going to take me to is in this direction, this is going to take me in this direction, this is going to take me over here, and this is going to take me over here. As you can see, there's sort of like a beautiful circular motion. So I don't want to I'm going to make it this again so I can just show you guys, or maybe I'll just put it here. Sorry for the incompetence of being slow at this. I think I'll just have to minimize the page so it's easy for me to scroll it down. Okay, there we have it. So if I want to show how the economy converges back after any shock, I can show it like this. I'll just use another color. So suppose it's just gonna go like this. It's gonna go like this, gonna move around more, and it's gonna converge back to the equilibrium. How beautiful is that? So this is the equilibrium after any shock. So if any shock does occur, the economy is going to move back towards this equilibrium following these direction lines. Okay, I think I've just gone overboard. I didn't want to cross 40 minutes for each video. So this is enough for today. So I would just like to basically, before I end the video, I'll just bring, just read out and just state the conclusion of today's lesson, which is basically, what we've covered so far is the adjustment logic for the IS curve, the adjustment logic for the LM curve, and the full ISLM phase diagram with correct directional arrows for both Y dot and R dot. This is the conceptual backbone of everything that comes next. So make sure that you've properly understood this. In part 2, we'll start applying this knowledge. First, we'll look at a supply-demand adjustment problem, and then we'll construct phase diagrams again, but this time using explicit functional forms where Y dot and R dot are given as differential equations. And then in part 3, we'll go on a deeper level and learn how to do the same thing even when the functional forms are not given, using reasoning and basically just intuition alone. So take your time with today's diagrams, the arrows and directions and everything, and see you guys in part 2, inshallah. Take care.